Alright, so in this video we'll continue to practice proving trig identities, and we're still going to stick with these four strategies just as a good baseline. So we start by picking the more complicated side. Okay, and there's actually both of these sides are fairly complicated looking. You're squaring a binomial one and you have a fraction on the other one. So kind of equally complicated. When it comes to that, you can decide which one to use. So I'll tell you in advance, this is actually going to be the sort of problem where you'd probably want to use or end up using this strategy to make them meet in the middle. Okay, so let's start with the right side. I'm not exactly sure, or hypothetically speaking, we might not be exactly sure what to do with the left side. Let's start with the right side, and we will square things. Okay, because strategy 3 says use all the normal algebra techniques. Well, in algebra, you would normally, when you have something being squared, you would just go ahead and square it. So cosecant of theta minus cotangent of theta, and then squaring means multiplying it by itself. Okay, so we will put those side by side, and then we'll FOIL this out. So cosecant times cosecant is cosecant squared. Cosecant times negative cotangent is minus cosec cotan. And then the inside terms will be minus another cosec cotan, so that's minus 2 cosecant cotan. And then negative cotan times negative cotan is positive cotan squared. Okay, so now we're at this point. So now the question is where to go from here. Well, strategy number 2 up here says try to make well-known identities appear. Okay, and of course if you look at these Pythagorean identities, there is one for cosecant squared. Is this one 1 plus cotan squared? So let's see if we can make something out of that. So we will replace cosecant squared with 1 plus cotangent squared, and we still have minus 2 cosec cotan, and then we have plus cotan squared. Alright, so now if we combine this a little bit further, we would have the following. Okay, we would have cotan squared plus cotan squared is 2 cotan squared, and then we have minus that 2 cosecant cotan, and then finally we have this 1 right here, this plus 1. Now here's a good point to pause and maybe look back at the other one and say, how could we make this into the left side or make it look like the left hand side? And it's not obvious. So when it's not obvious, you can use this strategy we talked about, which is to make things meet in the middle. Okay, so strategy 3 says make things meet in the middle. So we are currently kind of stuck at a certain point. We're not exactly sure where to go. Let's go back up to strategy 3. Let's start messing around with the left hand side and see if we can get that to meet in the middle. Okay, and then the other thing that the left hand side, or the other thing that strategy number 3 says, is use all the normal algebra techniques, and they talk about this. They talk about using the conjugate. Here's where we would use the conjugate, and I'll tell you why. The conjugate, it's always based on the bottom of the fraction. The conjugate of 1 plus cosine is 1 minus cosine. We're going to multiply the top and the bottom by that, and I'll tell you why. First of all, this whole thing right here is equal to 1, because anything divided by itself is 1. You're allowed to multiply something by 1 because multiplying by 1 doesn't change the value. Why are we using the conjugate? Because we'll be able to make one of these identities appear. Notice that if you multiply cosine times cosine, you will get a cosine squared, and that probably means that that identity is somehow going to be involved. So let's see if we can do that. So we will FOIL out, let's FOIL the bottom first, it's a little bit easier. 1 times 1 is just going to be 1. Then you have 1 times positive cosine, 1 times negative cosine. Those are going to cancel. And then finally you have negative cosine times positive cosine is negative cosine squared. Okay, the top is going to equal, when we FOIL the top, we have 1 times 1. We have 1 times negative cosine, and then 1 times another negative cosine. That's going to be minus 2 cosine. That was combining the outside and inside terms. And then we have negative cosine times negative cosine is positive cosine squared. Alright, so now if you look at what we have on the left hand side up till that point that we just wrote, it does look at least slightly closer to what we want it to end up with. We have a couple things with coefficients here. So we have a 1 right here, we have a 1 right here, we have a 2 cosine, we have a 2 cosec cotan. So it doesn't look quite the same, but it looks at least like we could move in that direction. So let's keep using our other strategies. So strategy 4 says when in doubt, but let's not go to that yet. Strategy 2 says try to make well-known identities appear or some variation. So let's look at this one. This identity, if you subtract cosine squared, you get this. What does 1 minus cosine squared equal? It equals sine squared. So if you look at this identity, there's a 1 minus cosine squared right on the bottom. So let's change that into the following. Let's change that into 1 minus 2 cosine plus cosine squared, and then all of that is now going to be over sine squared, because that's exactly what this thing equals right here. Okay, why is that going to help us? Well, one of the reasons why that might help us is because when we have a bunch of stuff over a fraction like that, if you're, just to prove this to you, let's do it with numbers first. Suppose I had 1 plus 3 over 4. You're allowed to take that and split it down the middle. So you can have 1/4 plus 3/4. And you can verify that. 1 plus 3 is 4. 4 over 4, that equals 1. And 1 is the same as 1/4 plus 3/4. So I'm going to take this and just split it so that all three of those components on the top are now over sine squared. Okay, and in terms of why we would do that, how did we know to do that? There's a couple ways that we knew how to do that. Here's one way. I mean, notice that right here, the thing that we're trying to change it into has a bunch of terms just being added together like that. So that's one of the hints that we had, that would be the right thing to do. Okay, so this should actually be a 1 right there. All right, so let's keep going. Again, a lot of these problems you might not necessarily know where it's going to end up, but you just got to keep forging on. So now we have 1 over sine squared. Well, that's an identity. Let's go back up here. 1 over sine is equal to cosecant. Okay, and then I saw another identity there where we also had cosine squared over sine squared. Okay, it's right at the bottom there. Cosine squared over sine squared. Well, cosine over sine, that's what this is right here, because it's 1 over tangent. Tangent is sine over cosine. So all we're doing right now is we're going term by term. We're saying, are there any identities that apply to this? And there are. There are quite a few. So this thing equals the opposite of sine is cosecant. This last one right here is cotangent. And then this one we can simplify just a little bit. And here's something to think about. Notice that over here we have a cosecant in the middle. And I'm looking right here, that's sine squared. Remember that the reciprocal of sine is cosecant. So we can rewrite this middle term as 2 cosine. And then if we were to flip sine squared to the top, it becomes cosecant squared. That's exactly what sine squared is. It's the reciprocal. Okay, so we are now at this point, we're fairly close to what we need. Now you might say, well, how it still looks different. Yes, but there are other trig identities. So let's look at cosecant squared. Remember that identity we used before. Cosecant squared is the same as 1 plus cotan squared minus 2 cosine cosec squared. And then we have plus cotan squared, so we're very close. Here's why. Cotan squared plus cotan squared is 2 cotan squared, and that's what we need right here. There's the 1. Okay, the 1 is right here. Now, how do we get 2 cosec cotan out of this? And here's how we could do it. When in doubt, change things into sines and cosines. So we already have a cosine right here. Okay, and I know we just changed the sine into cosecant, but I just want to do this one more time so you can see. So this is the same as 1 over sine squared. Why would we do this? Because notice that we're looking for a cotangent. And cotangent, just to recall, is the same as cosine over sine. So if you look back at where we are right now, how could we get a cosine over sine out of this? We could do it this way. We could have minus 2 cosine times 1 over sine times 1 over sine, because hopefully you would agree sine squared is the same as sine times sine. Now what does this equal? Cosine times 1 over sine, that's the same thing as cotangent. So that becomes 2 cotangent, and then 1 over sine, another name for that is cosecant. So that whole simplified term in the middle is 2 times cotangent theta times cosecant theta. Now if you look what we didn't mean to box off right there, obviously that these things get kind of messy when you try to have so many terms going at once. When you look at what we have right there, plus 1, this thing right here is actually where we left off on this other problem. Okay, it's the exact same thing. We met in the middle. We proved that these two are identical to each other. So that was a fairly complicated one, but all of the way along we just kept using those strategies that we mentioned before.